Hello everyone, I welcome you all to yet another discussion session of the CAT 2023, and in today's class we will be taking up the slot 3 of CAT 2023 paper. So let's get started with the questions. He says let n be any natural number such that 5 to the power n minus 1 is less than 3 to the power n plus 1. Okay. So n should be a natural number which should satisfy this. Now let's read the later part little later. Let's focus on this inequality. For what values of n will this be true where n is a natural number? Now if I put n equal to 1, suppose. So 5 to the power 0, 1 less than 3 to the power 2, absolutely correct. 1 is less than 9, that's correct. Put n equal to 2. 5 to the power 2 minus 1, 5, this part is 5. 3 to the power 2 plus 1 is 3 cube, 27. Yes, that is also absolutely correct. So this inequality will be satisfied for n equal to 2 also. What about n equal to 3? 5 square and this is 3 power 4, 81 and 25. Yes, 81 is greater than 25. N equal to 3 also is okay. Put n equal to 4. So 5 cube and this is 3 power 5. 3 power 5 is 243. 5 cube is 125. 243 is more than 125, satisfies. Let's check for 5 also. So 5 to the power 5 minus 1, 5 power 4 is 625 and this will be what? 3 to the power 6, 729, that is also correct. It also satisfies. Let's put 6. 5 to the power 6 minus 1, 5 power 5 is 3125 and if you put 6 here, 3 to the power 6 plus 1 is 3 power 7 which is 2187. No, it's not true. So that means only for these values, 5 values of n, this inequality will be satisfied. Nothing beyond that. So 6, 7, 8, no, they will not come in our list. So this is the first thing that we understand. And now let's read the question further. Then the least integer value of m, not n, the least integer value of m that satisfies another inequality is given. 3 to the power n plus 1 should be less than 2 to the power n plus m. For each such n, see we already know that there are 5 such n's, only 5, not 6, not 7, not 8, only 5 values. So he says what should be the least integer value of this m which should satisfy this inequality for any value that you put for n. So whether you put n equal to 1 or 2 or 3 or whatever, what is the value of m that will satisfy this inequality? Let's check. Let us check. So if you put n equal to 1, suppose, let's try to see the trend here. If you put n equal to 1, what happens? Left hand side will be 3 square and this should be less than 2 to the power m plus 1. So some power of 2 should be greater than 9. What is that power of 2? It is 16. So m plus 1 will be 4. So m can be 3. M plus 1 is 4. So m can be 3. The least value he says. Least integer value of n. But m equal to 3, will it also satisfy for n equal to 2? Let's check. If I put n equal to 2, let's see what happens here. This is 3 cube, 27. This should be less than 2 to the power 2 plus m. So some power of 2 should be greater than 27. What is that power of 2? 32. 2 power 5. So m plus 2 should be 5. That means m is 3. Yes, it's satisfying. So m equal to 3 seems to be working. Let's continue. N equal to, I'll go for a higher value, 5. So if I put n equal to 5, this will be 3 power 6. And by the way, 3 power 6 is 729. Less than some power of 2. 5 plus m. So some power of 2 should be greater than 729. What is the power of 2? It is 1024. 2 power 10. So that means 5 plus m should be 10. So that means the value of m plus 5 should be 10. That means the value of m should be 5. No, m equal to 3 is not satisfying always. For example, at n equal to 5, the value of m has to be 5. Minimum 5. Right? I think there is no point going beyond that because the maximum value of n that we have is only 5. And I am sure any value below this, m equal to 5 will definitely satisfy. You can verify that. See, this inequality is satisfied for m equal to 3 itself. So it will satisfy for m equal to 5 naturally because this will become even bigger. This will also satisfy. If you want to, you can check for n equal to 3. So if I put n equal to 3, so the left hand side will be what? 3 to the power 3 plus 1, 3 power 4 should be less than 3 plus m. Now think about it. This is 81. And if I put m equal to 5, it will clearly satisfy. No need to check. Now next, n equal to 4 as well. 3 to the power 4 plus 1, 3 power 5 is less than 2 to the power 4 plus m. So 3 power 5 is 243 and 2 to the power 4 plus m. So this will also clearly satisfy for m equal to 5. So that means what is that value of 5? Minimum value of, what is the minimum value of m that will satisfy this inequality always? So can I say the minimum value as we see is 5? See, the word over there is, the important keyword over there is for each such n. The value of m chosen should satisfy all the values of n. So for example, if you say no, the minimum value of m is 3, but please understand m equal to 3 is only satisfying maybe some of the inequalities. For example, m equal to 3 will not satisfy this inequality, whereas m equal to 5 will satisfy all the inequalities. So it should satisfy all. He says for each n. So my answer thus should be 5. Okay, I hope this was clear. So it was very important to note why are we marking 5 as the answer when we got the value of m as 3 also. Then why are we marking 5? I hope that point is also clear to all of us.